Okay. Recording. Let me just say it's starting. So let's start with session 5. Let me quickly switch off. Just check where I can change the settings, but it doesn't type full time I talk. Great. Okay. Okay. So let's start with session 5. Basically, it will be study unit 5. I think we will probably do discrete and binomial tonight, and then on Tuesday or somewhere next week we can finish off with Poisson, and that is when still in time for you to look at your second assignment that for now is due end of May. There are talks about maybe getting extensions on that, but we'll see what UNISA say. At the moment, we don't know. Okay, so basically in study unit 5, remember on Tuesday we started with probability. So, and there it was basically we looked at nearly one or two events that's happening, and you needed to say, well, what's the probability of the two events happening? Sometimes when it's mutually exclusive, when it's independent. Now we're moving into discrete probability, and with discrete binomial Poisson, and later in study unit 6, when we get to normal distribution, all they need to give you a table with probabilities, or you will need to work out the probabilities. And it's like the table that we had in the chat this afternoon. When you're dealing with discrete probability, they would need to give you the information. So it's not that suddenly you now will know what the probability is. They must give it to you. So let's quickly just check a few things before we get into the workings. And again, you can use my nearly one pager that I've written as well as a summary, because it is important to know basically these. So for discrete, you need to know the mean, the variance, the standard deviation. So that is important. And you will see when we get to the questions around that. So it can be that they ask you a few questions or give you a few options just on how to calculate the probability, but most of the times they will include 2 or 3 probabilities, 1 mean, and 1 variance. So just important to know that. Okay, so let me also do that. I'll just quickly increase the volume. Okay, cool. So let's hope that will work. What I will also, let me just check again. Okay, so hopefully that is better. But I will also speak more in the mic as well, that you can hear. Okay, so hopefully that does sound better at the moment. So what is important, you will have with discrete, how to work out the probability. Then with the probability, mean and variance. And then the same if you have the binomial. Again, you will have to look at the probability. I want to show you guys how to use the tables instead of this, because I really don't want you to use the formulas. And then we need to know how to work out the mean, and we need to know how to work out the variance. The same then if we get to Poisson, basically you can work it out with a formula. I want you to use the tables again, so I'll show you how to do that. And then basically the mean they will give you, because that you will use in your table. And the nice thing about Poisson is that the mean and the variance are exactly the same. So you don't need to work out the variance. Okay, so let's get into nearly the first set of questions. So what for me is important here is that you will nearly see that when it is discrete, they need to give you the information. So we will now look at which one is correct, which one is not correct, and work around that. But they need to give you the probabilities in a table. So we can just jump through a few. So you will need to get the probabilities, otherwise you can't do it. It can be that maybe one of the probabilities, like this one, they left out, but again, we can get that with the rule. So when it is discrete, they need to give it to you in a table like this. Okay, so then the one thing that we need to know about nearly all probabilities, so even if it is discrete, binomial, Poisson, normal distribution, the probabilities need to add up to 1. So that for me is nearly the first thing, that if I look at these ones, your probability need to add up to 1. Okay, so that's critical. So when you add those 4, if it is 1, then it is valid. So let's see what, so if I add those to 0.896, so let me get my calculator. So 0.512 plus 0.384 plus 0.096 plus 0.008. That, if you add all of that, it is 1. 0, 1, 2, 3 at the top is correct, so option 1 would be correct. Let's just look at the others, because that would have been the correct one in the exam that we would have picked. But let's look at the other ones. 0.1 plus that is 0.4 plus that is 0.8 plus that is 0.9. So we know now that all the probabilities need to add up to 1. So that one can't be. If we add this one together, 0.98 plus that plus that plus that will give us 0.01. Again, it needs to add to 1. When I look at this one, 0.46 plus that is 0.5 plus that gives you 0.99. Again, not 1, not valid. 0.15 plus 0.2, so that's 0.4 plus that is 0.9 plus that is 1.2. Again, not equal to 1, not valid. So basically, the first question that I wanted to show you is very simple, but your probabilities need to add to 1. So when you later on start working with binomial and we look at the table, it will add to 1. The same with Poisson. When we look at the table, it will all add up to 1. So important for this instance, it is a discrete. The reason also why we know it is discrete, even though they don't tell us that, is that first they give it to us, so we can't work out what is the probabilities. It is also what we've learned from chapter 1, unit 1, when we looked at continuous, discrete, and other variables. Discrete is 0, 1, 2, 3, 4, 5. So there's nothing in between it. So another reason why this is discrete. Okay, when we get to the binomial and Poisson, I'll share some of the rules with that instance as well. Okay, so let's look at the second question. So again, they tell us, so they don't tell us it's discrete, but because we get the table, we know it is a discrete probability, and they want us to look at the correct one. So what for me now is interesting is we need to work out probability, we need to work out the mean, need to work out probability, need to work out probability. Okay, so I always, when I look at this, the things that I will work out last is mean and variance. So for me, it's always rather work out specifically when you look at the discrete distribution, I would work out the probabilities first. So the one thing that is important when we look at discrete is that we need to make sure that we know what we are looking at. So for the first one, they tell us, okay, look at the probability that x is bigger or equal to 2. Okay, so when I look at this table, bigger or equal to 2. So it will be basically the probability of those three. So if it is the probability of those three, it is 0.5 plus 0.15 plus 0.05. So that is 0.2. So that answer should be 0.7. Okay, so it is basically adding those three at the end because it is 2 and bigger. When we look at the next one, smaller or equal to 1, so smaller or equal to 1. It's basically just the opposite of the previous one. Oh, please don't now reboot. Okay, if I disappear in 3 minutes time, it is because my computer is starting to reboot, so hopefully it does not happen. Okay, hopefully I can close it. Okay, so basically when we look smaller or equal to 1, we're looking at 0 and 1. So that is 0.1 plus 0.2. So that is 0.3. So that one is also wrong. I'm going to skip that one for now. So let's look at option 4. Okay, and let's get another color. Smaller or equal to 4. bigger than 1. Okay, so look at option questions.
Hello?
Yes.
I just wanted to help there. If the computer is scheduled for a reboot, you can cancel it by opening the command prompt.
Yes.
Type in shutdown -A and press enter, then it will cancel the what?
Okay, cool.
It will cancel.
Okay, cool. Thanks. Let's see if it works and if I. Okay, so let's hope that will work. Okay, cool. So you can now see from 1 and 4, we basically have the same answer. So we're looking at the same thing. Just ask two different questions, two different ways. So that is correct. So just very interesting that basically on two ways that they can ask it for you to get the same answer. So let's look at the last one. Smaller than 4, so it's not including 4. Bigger than 2, so it's only 3 basically. So that answer should be 0.15. So that one is also wrong. Okay, so the last one is, how do we calculate the mean? Okay, so the mean of a discrete is basically the sum of x, and let's say xi, times the probability of xi. Okay, so that is the sum of that. So basically what we need to do is to say 0 times that plus 1 times that plus 2 times that plus 3 times that plus 4 times that, and that will be your answer. I think that will actually give you 1,85 and not, but let's quickly see. So 0 times that will give you 0. 1 times 0.2 will give you 0.2. Okay, that's not cool. Why did that disappear? Okay, did it also disappear on your side, or can you still see the screen?
Disappeared.
Okay. See, it's a whole office reboot. Okay, let me quickly see if I can just pause it in the. Okay, it now rebooted my presentation, so let's Hope it actually saved it as well. Okay. Okay, let me, guys, I'm going to quickly get out of this and reboot because it is now forcing me to do it. I'll be back in a few minutes. Okay, sorry about this. So let me, can you still hear me?
Yes.
Okay. Okay, cool. So while the computers start, let me see if I can get this recording. You've joined a meeting that is being recorded. Okay, cool. So the recording is actually going on. So that at least is not a problem. So now I just need to get my PC up and running again, and then we can go on. Okay, so basically, while I'm waiting for my PC to reboot and everything, on the discrete distribution that we looked at now, so you would have seen there's a few options how we can nearly calculate the probability. The most important that we need to understand is how to use the bigger and equal sign. So when you include the one probability and when you don't include it. Then on the way to work out the mean, so basically to work out the mean, it is the x value times the probability. So the first one is always 0, so the 0 times will always be the 0, and then you just basically multiply and add the rest. So that will give us the mean. The difficult one again is to get to the variance, which again is not a easy, straightforward one to calculate. So there again, if you look at the formula that we need to use, it's not as simple. So for that, we need to basically say your probability minus your mean, take the square root of that, times, or not, you need to power to the 2 times the probability. So again, you would nearly need to do 4 or 5 calculations. So what I would do, and when my system is starting, what I would do again is to nearly work that out in Excel, but obviously not with any formulas that is in Excel. It will need to be on. I will show you now. Basically, that I think we set up a table. I think like one of you guys also shared in a previous session in the on WhatsApp that how you would have done it on a paper, nearly one of the variance calculations. So again, I'll do that in Excel so that it's just easier for you, and I'll share it. So then the next time that you need to do it, you can just use that same formula page. You don't need to redo it or anything like that. Okay, so let me get, while my laptop is opening, it is now going to be interesting if I can get into the files very quickly. It actually seems like it is quicker than it used to be. Okay, session 5. There's Teams. Okay, so hopefully it will open now. Okay, nearly there, nearly there. Okay, can you still hear me?
Yes.
Okay, awesome. Back on the laptop, and now let's just make sure I can open the presentation again. Okay, why do you want to open that? So let's quickly see if I can download it from the Teams. Okay, is this going to work? Okay, so I can see it. So something old thumbs.
If it doesn't work, maybe one of us could share while you get up and running.
Yeah, let's quickly do that.
Okay. I'm willing to share if nobody else wants to. If I can share my screen, let's see.
Okay, cool.
I just can't write.
Yes, so now I want to check. Okay, this is now going to be interesting. So my PowerPoint somehow. Okay, so I'm going to share again, but it's going to be PDF. So we're going to improvise tonight.
There's nothing wrong with that.
Let's see how technology take us on this road tonight. Okay, can you guys see the PDF at least?
Yes.
Okay, awesome. So then we're going to work with that, and let's see if I can use these things up here and see how that goes. Okay, so basically we were lost at working out the mean. So the mean would have been the simple one of that times that, 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 and you basically get the answer. If you needed to do the variance, let me quickly show you how I would have done that. Okay, so it doesn't want to open my Excel or my PowerPoint, so there is obviously a problem with my PC at the moment. So I'll show that to you guys the next session, how to use Excel to calculate some of these answers. Okay, so in this one, so the next one basically we need to work out the mean. So we need to work out the mean. So in this instance, when you need to work out the mean, it is basically those two that you multiply plus those two, and then you add all of them together. So let me see if that is not gonna work. That is not really gonna work. I now wanted to add, so let's just add a note here, and we'll see how we can do this. So basically you needed to say 0 times 0.6 plus the next one plus the next one. Okay, so this you can work out with your calculator, but again, when I look at this, that one would be 0. 1 times 0.2 is 0.2. 2 times 0.1 is 0.2. 3 times 0.05 is 0.15. 4 times 0.03 is 0.12. 5 times 0.01 is 0.05. 6 times 0.01 is 0.06. So if I then add all of those together, I get 0.78, which would have given you option 3. I think what is important nearly when you're looking at this is, and nearly a tip, if your biggest percentage is sitting with a 0, then your answer will be less than 1. So if 60% or 0.6 was sitting here at the top end of your probability, then it would have been a bigger answer. But because 0.6 is sitting with a 0, your answer will be very small. So when I look at this, and again, it's just nearly a tip for the exam, option 1 will never be, because it's too big. The other ones for this, for me, comes into play. That one probably also not, because it's too small. So if in the exam nearly you don't know, have a clue at all, look at where the 0 is with the biggest probability. If the biggest probability was sitting here, then I would automatically look at nearly your 2 or 3 biggest numbers, and then nearly, if I didn't know what to do, guessed one of the answers. Again, if you want to use a calculator, or if you want to use Excel for this, one can probably set it up for you. So I'll look at how we can nearly look at question 3. I'll check if I can nearly create something for you that, if needed, we can cover most of these questions to work out your mean and your variance. For your probability, that basically you need to work out with what is in front of you. But for your mean and your variance, I'll create an Excel spreadsheet that you can do it. If you needed to, say, work out probabilities of probability that X is bigger or equal to 5, you would have basically looked at that part of a table. If I ask you, and maybe I'll ask you guys, if I ask you, what's the probability bigger than 1, smaller than, and equal to 4? Bigger than 1, smaller or equal to 4. Bigger than 1, smaller or equal to 4. Which ones would you have included?
2, 3, and 4.
That's
Okay,
0.
awesome. So bigger than 1, smaller or equal to 4, 2, 3, and 4. So it would have been those 3. So that is nearly, when you guys look at this whole study unit, discrete, binomial, and Poisson, I think that's nearly the important one to be able to work out, with the bigger than, just bigger or equal to, smaller or equal to. So let's get to the next one. So here, basically, they give us probabilities again. They tell you it's discrete. They ask you which one is incorrect. Okay, so it's 0.2, 0.5, 0.65, 0.8. So it does equal to 1. Okay, so probability x bigger than 1. So what will those ones be that you need to add? X bigger than 1.
2 and 3.
Awesome. Okay, 2 and 3. So basically 2 and 3, which is 0.2, 0.15, correct. Okay, we're looking for the incorrect one. X smaller or equal to 2. Which ones would you then look at?
From 0 to 2.
From 0 to 2.
Awesome. 0 to 2. Okay, so let's bring in another way to do it, because that I'll show you in binomial and Poisson as well. So 0 to 2 would have been able to add all of those. Or you could have said 1 minus what was left. Okay. Okay, why didn't it now do that? Okay, so it should be 1 minus 0.15, which would have also given you the answer. Okay, so I'm now, let's just do that again.
Use the pen too.
See, the pen was, okay, so if I do that,
Then choose the
I,
dot there. The
the
dot.
dot. Okay, awesome. Thank you. You guys are now teaching me a few things tonight. Awesome. Okay, and then I can just, okay.
You need to click on the dot, not the one at the end, the one that is just before the sign. That one.
See, my whole computer is, I think, giving me problems now. I will need to reboot again and okay. So basically 1 minus the 0.15 would have also given you, see, it's not doing what it's supposed to do. Technology when you want it. Okay, so basically also giving you the 0.85, which is correct. Okay, bigger or equal to 1, smaller or equal to 2. Where would that sit?
Between 1 and 2.
1 and 2.
Okay, 1 and 2, which is 0.6, which is correct. Smaller than 1?
0.
0.
0.
Okay, cool. Okay, so now it becomes very easy. Smaller or equal to 1, bigger than 0.
1.
1.
Awesome. So it's just 1. So that one is the incorrect one, because it should have been just 0.4. Okay, so discrete probability, with what I've now heard, you guys are actually very fine with it. So discrete, just look at the table that they give you. Very important, just the sign of what you need to include and not include. Let's see if I've got another one on discrete. Okay. So this one, they don't give you what's the probability at 6 days. So that you first need to work out. So how do you get that?
1 minus.
I think you have to minus all the probabilities from 1.
Perfect. So 1 minus 0.05, 0.2, 0.6, 0.2 will give you that. So it is 1 minus 0.2, 0.6, 0.8, 0.85. So that is basically 0.15. Okay, at least now I could done that. Okay. Also, what you will notice, and it's different now with you guys that are writing online, because your answers are being nearly, the options are being swapped around. Because you would now see in the old way of paper, that first answer is normally the one that you worked out something. And you'll see later on when we get to study units 6, 7, and 8, very similar. It would have been sometimes when you work out the Z, but don't worry about that now. We'll get to that. So your first answer is normally a giveaway of one of the things that you would have calculated. So it can also be with the random answers that you worked out 0.15 and suddenly you see 0.15 somewhere in the options and you just pick it because that is now the number that you've worked with. But obviously it is not 0.15. So this one, as with the previous ones, you basically need to say 2 times that plus 3 times that plus 4 times that plus 5 times that plus 6 times that. So when I look at this, you can see that times that is already 1. So that can't be one of your answers. Probably these ones are very close to one another, so might be one of those two. But let's see, 2 times that is 0.1. That is 0.6, so plus that is 0.7, plus that is 1.7. So at least we're sitting with 1.7 so far. 4 times 0.4 is 1.6. So that is then already 3.3, okay, which is there. But then we still need to add the probability of 6. So those two multiplied is 0.9. So 3.3 plus 0.9 gives us the 4.2. But again, nearly when you look at this, if you didn't include that one, there was an option for you. So just be nearly wary of the options that are in the set of answers so that you don't nearly fall in the trap because you forgot to multiply that and there was an answer. Okay, so that is discrete probability. Questions around discrete probability. Are you guys much more comfortable with discrete probability at the moment? Okay, cool. So hopefully much more comfortable with that. So let's look at one or two of binomial. With binomial, I don't think if we quickly run through it. Okay, so sometimes they don't tell you it's binomial, sometimes they do. So you need to remember nearly, so when is something a binomial distribution? So anybody on your side, when is it a binomial distribution? Okay, it's binomial when you have two options. Basically, something is happening or it's not happening. And I think that is also what in some of the questions that I'll show you where I've seen sometimes that they give you one option, but they ask the opposite. So, but I will show you if we get to a question like that, or how you could have answered it differently. Okay, so when we look at binomial, and remember when I showed you the binomial formula. So if I now suddenly need to work out if I needed to work out x equal to 2, I would have used that formula once. If I now need to work out x smaller or equal to 1, I would have used it for 0, I would have used it for 1. So I would have needed to use that formula twice. The same if I look at x bigger or equal to 5, n is 6, so again I would have used it twice, 5 or 6. If the question was that you need to work out x smaller or equal to 3, you would have used it for 3, 2, 1, and 0. So you needed to work out with the formula nearly 4 times that. So it just takes a lot of time. So I always like to use the table. So they give you the information that you need from a table. So they would tell you n, so n is equal to 6, and they would tell you what the probability is, or the sigma that we're testing against, and that is 0.2. Okay, so we basically, for this set of questions, so for this set of questions, why doesn't it want to? It's weird. We're only going to look at this part of the table. So again, when you're sitting in the exam and they will give you the tables, again, you have it in your study guide in any case, but the lecturer will also share a nearly pre-exam document with you that will have all the necessary tables in that you need, all the necessary formulas and those kind of things. But we only need to look at the where it's 0.2. So x equal to 2. So again, easy. They tell us there's x, so x equal to 2, x equal to 2. There it is, 0.2458. Correct. Okay, we're looking for the incorrect one again. Okay, next one, x equal to 5. So let's look at 0.0005. So let's see, x5, go across 0.0015. Ah, there's your incorrect one. I hope that wasn't a typing error, but x equal to 5, definitely 0.0015. Okay, so that is your incorrect one. But let's look at x smaller or equal to 1. So which ones would you have added to get to x smaller or equal to 1?
The 1 in 0 and the 1 in 1.
And 1.
Yeah. The sum of
Awesome.
them.
So the sum of those two.
That is
So the
correct.
sum of, perfect. Okay, and that's why I like to work with a table, because I want to stay away from the formulas in this and in Poisson distribution. Okay, so let's, and that would have been 3, 5, 5, 1 carrying over, so that is correct. X bigger or equal to 5. So which ones would you have added there?
And the ones in 5 and 6.
Awesome.
Some of them.
5 and 6. So 0.015 plus 0.001 gives you that. Okay, last one in this set. how do you calculate the mean? And again, we don't need to remember it. You can page through your study guide. The mean is basically n times sigma. So let's quickly get to that. N we know is 6. It was times 0.2. So 6 times 0.2, it is 1.2. So basically, easy to work out the mean from a table, much nicer to work from a table. And if we needed to work out the variance, let's just quickly check what was the formula for the variance. So basically the mean times 1 minus the sigma, so it would have been 1 minus that. Okay, so let's just see if I can now. Okay, I hate this tonight. Okay, so now that even also disappeared. Let's see if I can get that back. See, I have big problems with my PC. Nah. Okay, so it should have been then times with 0.8, and that would have been your variance. Also, what you need to be careful about is, and let's see if there is a question like that. No, so the rest is all, and then we get to. So what they can also do is ask you to work out the standard deviation, which then is, remember, the square root of your mean. So just be very careful nearly when they ask the variance and the standard deviation, that sometimes you feel it's straightforward because you work out the variance and then suddenly it's actually the standard deviation that they ask. So specifically binomial and Poisson. I just want to check if they, okay, so there they ask variance. So at least they didn't ask standard deviation, but just nearly as a tip for the exam as well, just be careful when they ask mean and when they ask standard deviation. Okay, so let's quickly to see if I can save this at least. So that I can share it with you in any case. Okay, so I think the last one that we can look at. So here they want expected mean or expected number, so the mean. So it's interesting because they don't say n is, they don't say to your sigma is, so you now need to get it out of this. So a certain type of tomato seed germinates 90% of the time. A backyard farmer plant 25 seeds. The expected mean of seeds. Okay, so basically to work out the mean will be the 90%, so 0.9 times 25. So 0.9 times 25 is 22.5. Okay, so that would have been your answer. Okay, so it is 0.9 times 25. Okay, so this one was straightforward how to work out the mean. What I wanted to nearly show, what they can ask. Also, yeah, yeah, my computer is going to restart again, so we'll just finish it now. Is that they could have said that not. Okay, so they could have said not. So if it is not, what would you have used? Would you still use the 0.9, or what would you use?
I would have used 0.1 multiplied by 25 if it's not.
Okay, cool, perfect. So because the probability needs to equal to 1, so when it needs to equal to 1 and binomial happens or doesn't happen, so if it happens, it is 0.9. If it does not happen, it is 1 minus 0.9, which is 0.1. Okay, so again, maybe in the assignment as well, also just check that what they give you as the percentage is also the percentage that they nearly ask in the question. Because if it was not, it is 1 minus whatever the percentage was. Okay, let's stop here for tonight because my computer is again going to reboot. One of those days. Let's quickly, any questions from your side? Does it make a bit more sense? Is it, are you feeling a bit better about discrete and the start of binomial? Okay, cool. Yes. Questions? Tembi, do you want to ask a question?
Yes. Can you go back to question 8? Because I can't seem to find how you got 0.15.
Okay, so it's basically 1 minus, I need to add all of those together. So that was 0.2 plus 0.4 is 0.6 plus 0.2 is 0.8 plus that is 0.85. So 1 minus 0.85 gives me the 0.15. Okay, again, as in discrete, as in binomial, and in Poisson, everything needs to add to 1. So that's why you can do it. That's why you can nearly calculate that last one. If there was 2 open, you can't calculate the 2 because you don't know how it is distributed. But because there's only 1 cell open, you can, because everything needs to add to 1.
Okay.
Cool.
Thanks.
So the last one we did, if we said 90 multiplied by, like we say 25 minus 90 multiplied by 25, is it okay? I guess it would come back to the same.
Quickly say that again.
When you said not at this point,
Yes.
So was it okay to say 25 minus 90 multiplied by 25?
See, with this one, yeah, oof, okay, yeah, it's, see, because this is binomial, you basically, they could have, so let's look at it a bit differently. They could have given you the table as well, or we could have looked at the table to work it out. But with binomial, the easiest for me to work it out is by using this simple formula of n times the sigma. You could have used nearly the binomial table and probably multiply out as well, but that is just too long. So I would just use it this way.
I was looking at the last the last response where it says 0.1 multiplied by 25, or something like that, when you say not.
Sorry.
So I was looking
So-
at it from
so
that angle
it-
to say, using the figures that we have around there, we have 90% and 25. Why wouldn't we just say 25 multiplied by, 25 minus 90% of 25?
Oh, yes, you can do it that way as well. Yes. Sorry, yes, you can do it. So you wanted to say 25 minus 0.9 times 25. That is what you wanted to do.
Yes,
Is
sir.
that what you wanted? Perfect. You must get the same answer. Yes, you will get exactly the same answer. Perfect. Yeah, no. Sorry, I misunderstood you there. Perfect. That you will get exactly the same answer. Because again, you're using the same principle. So no, perfect. Cool. Other question, guys? Otherwise, I am going to let my computer restart and hopefully I'll schedule a session for next week that we can complete the binomial and Poisson, so that we at least have covered your first two assignments. Then we can start focusing on the other stuff, the normal distributions and stuff like that. Okay, cool. Thanks everyone. Have a good evening. Craig,
Thank
do you
you.
want?
Good evening.
Yes.
Sorry, just before you go, not relating to this, could you possibly just send the invite to these links again? Because what happens is I've actually joined in my business profile, so it's not
Okay.
picking it up as an organization.
Okay. Oh,
Please.
I see you outside your organization. Yes.
Yeah,
Yes.
please. Thank you very
Okay.
much. I appreciate
No,
that.
perfect. Will do. Okay.
Cheers.
Cheers, everyone. Bye.
Bye. Bye.